Why does the universe look like it was designed? From the delicate balance of physical constants to the mysterious elegance of mathematics, everything about our cosmos seems to whisper of an underlying order. But is this order the result of intelligent design, or is it simply the outcome of random chance across vast stretches of space and time? For centuries, humans have gazed into the night sky and wondered if the universe carries a signature, a kind of cosmic blueprint. Ancient philosophers argued for the existence of a higher intelligence, while modern scientists have revealed breathtaking details about the Big Bang, cosmic inflation, and the laws of physics that govern reality. Strikingly, many of these laws appear fine-tuned so precise that even a slight variation would make life impossible. The debate is not only scientific, it is deeply philosophical, spiritual, and existential. If the universe is fine-tuned, who or what designed it? If not, why does it feel so mathematically elegant and life-permitting? In this series, we'll explore the evidence, theories, and mysteries surrounding the universe's apparent design, from cosmology and quantum physics to theology, philosophy, and the multiverse. Each perspective offers insights into the biggest question of all: why does the universe exist the way it does? When we talk about a fine-tuned universe, we're pointing to a remarkable truth. The laws of physics and the fundamental constants that govern reality appear to be balanced on a razor's edge. Even the slightest deviation in these constants could have rendered the cosmos barren, chaotic, or entirely uninhabitable. Yet here we are, living in a universe that not only supports stars, galaxies, and planets, but also life itself. Consider the gravitational constant, which determines the strength of gravity. If gravity were even slightly stronger, stars would burn out too quickly, collapsing into black holes before life had a chance to evolve. If it were weaker, stars could never ignite, and the universe would remain cold and dark. Similarly, the cosmological constant, which drives the expansion of the universe, appears incredibly precise. A fraction of a percent difference would have caused the universe to either collapse back into a singularity, or expand so fast that galaxies never formed. Then there's the ratio of electromagnetic force to gravitational force, a staggering number of about 10. This enormous disparity allows for stable atoms, chemical bonding, and ultimately the complexity of biology. If this ratio were altered, matter, as we know it, could not exist. Another striking example lies in the strong nuclear force, which binds protons and neutrons together inside atomic nuclei. If this force were slightly stronger, hydrogen would have been consumed too quickly, depriving stars of their long-burning fuel. If it were weaker, no elements beyond hydrogen would form, leaving the universe devoid of the carbon, oxygen, and nitrogen essential for life. These constants are not arbitrary guesses. They are measured realities of our cosmos. Yet their precision is staggering, almost as if the universe was programmed to allow complexity. Scientists often compare this to rolling dice and getting the same number trillions of times in a row. The odds appear astronomically low, leading many to ask, is this pure chance or evidence of design in the universe? Critics of the fine-tuning argument sometimes point out that if the universe were not life-permitting, we wouldn't be here to observe it. This perspective, known as the anthropic principle, argues that our existence biases our perception. But even if that's true, it doesn't diminish the fact that the universe's conditions are extraordinarily rare, and our awareness of them highlights the fragile balance of reality. As physicist Paul Davies once wrote, "The impression of design is overwhelming. Whether or not one believes in a designer, the mathematical elegance and precision of the universe cannot be ignored. From gravity to nuclear forces, every aspect of the cosmos seems calibrated for order, structure, and ultimately, life. If the universe feels fine-tuned today, it was even more delicate at its very beginning. The moment of the Big Bang set the stage for everything that would follow: matter, energy, space, time, stars, galaxies, and life itself. But the more scientists study the Big Bang, the more they discover how finely balanced its initial conditions had to be. First, consider the density of the universe just fractions of a second after the Big Bang. If the density had been even slightly higher, the universe would have collapsed back on itself in a fiery crunch. If it had been slightly lower, it would have expanded too rapidly, thinning out before galaxies and stars could form. Astonishingly, the required precision has been estimated at 1 part in 10. To visualize this, imagine tossing a dart across the entire observable universe and hitting a target only a millimeter wide. That's how exact the conditions had to be. Another astonishing feature lies in the balance of matter and antimatter. When the universe began, equal amounts should have annihilated each other, leaving nothing but pure energy. Yet, for reasons still not fully understood, there was a tiny excess of matter, just 1 particle of matter per billion particles of antimatter. That tiny asymmetry is why we have planets, stars, and life instead of an empty void. Without that imbalance, the universe would be lifeless. Then comes the mystery of cosmic inflation, a brief period where the universe expanded faster than the speed of light. Inflation solved several puzzles like why the universe looks uniform in all directions, but it also introduced new fine-tuning questions. For inflation to work, the inflaton field, a hypothetical energy field driving expansion, had to have very specific properties. Too much energy, and the universe would have torn itself apart. Too little, and inflation would have fizzled out before structure could form. The odds of hitting the perfect balance, again, seemingly infinitesimal. Equally remarkable is the cosmological constant problem. Quantum physics predicts that the energy of empty space, the so-called vacuum energy, should be 120 orders of magnitude larger than it actually is. If that prediction were correct, the universe would have blown apart instantly. Instead, the cosmological constant is small, positive, and incredibly precise, allowing for galaxies and life. Physicist Steven Weinberg once noted that this value appears unnaturally fine-tuned, and to this day it remains one of the greatest puzzles in modern physics. The Big Bang also produced the exact mix of elements needed for life. Within the first 3 minutes, the universe created hydrogen, helium, and trace amounts of lithium. Later, stars would forge heavier elements like carbon and oxygen. But that initial balance of light elements was crucial. Had nuclear reactions in the early universe run even slightly differently, the chemical building blocks of life might never have emerged. All of these factors, density, matter, asymmetry, inflation, cosmological constant, elemental abundances show that the early universe was balanced with breathtaking precision. Some scientists argue this points to deep underlying laws we don't yet understand. Others say it looks suspiciously like the fingerprints of cosmic design. Either way, the Big Bang was not just an explosion of chaos. It was an extraordinarily ordered beginning, tuned in such a way that billions of years later, conscious beings could reflect on it. That fact alone leaves us with a profound mystery. Why was the universe born so perfectly balanced?